Hi, my name is Julie Sievers, and in this video I'm going to cover proper bacterial sampling collection procedures for drinking water, including where and where not to collect these types of samples. But first, I want to discuss the importance of monitoring your water for bacteria. Monitoring is really the only way to ensure the water you are serving to the public is safe to drink. Drinking water should not contain pathogens or disease-causing organisms, but there is no easy or good way to sample for these individual pathogens. Therefore, our water testing program only focuses on monitoring for indicator bacteria, which are total coliform bacteria. Total coliform bacteria are generally not harmful themselves. They are bacteria which are naturally present in the environment, in soil and water, and are used as an indicator that other, potentially harmful bacteria, such as E. coli, parasites, or viruses, may be present. The presence of total coliform bacteria indicate that pathogens may be present and that there has been a breach or failure in the water system that may have allowed pathogens to enter the system. E. coli is a fecal indicator, and its presence in water supplies indicate the water system may have been contaminated with human or animal waste. Microbes in these wastes can cause short-term health effects such as diarrhea, cramps, nausea, headaches, or other symptoms that can even lead to death for more vulnerable individuals such as infants, young children, some of the elderly, and people with severely compromised immune systems. Because of the seriousness of these types of contaminations and their potential threat to public health, and far-reaching consequences it can have on public trust of your water supply, it is up to you to ensure public health is being protected, and that is done in part through regularly monitoring your water supply. Proper sampling technique is very important to ensure that the sample is representative of the drinking water quality in the system. It is critical that samples be collected at representative sites in the distribution system. Each drinking water system is required to have a bacteria sampling plan that includes a map and a description of the sampling locations and a description of the proper sampling procedure. Your bacteria sampling plan is a living document, so you may change the locations if they are not available, if they're not clean, or for any other reason. Note the change in the log. It is important to sample at representative locations throughout the distribution system. Now, let's go over proper sampling techniques for drinking water. First, be sure that you have the correct sample bottles for coliform bacteria sample analysis. The sample bottle must be sterile and provided by your certified lab. Different labs provide different types of bottles, so it is important to be certain you have a bottle for coliform bacteria testing. The bottles are sterile, so be sure the seal, if there is one, is intact. If there's any question about the integrity of the bottle, do not use it and get a fresh one. If you chlorinate, the bottle must contain a dechlorinating agent. This may appear as a white powder, a small tablet, or as a few drops of liquid in the sample bottle. Avoid collecting a sample from the following locations: faucets with aerators, hose or sprayer or strainer attachments, faucets that are connected to a water treatment device, such as a softener, filter, RO unit, UV light, or other in-home treatment units, swivel or bar type or swing faucets, frost-proof hydrants, sprinkler systems for fire protection or meter pits, fire hydrants, blow-offs, or cleanouts, taps that are leaking at any point, cracked or worn, or otherwise in disrepair, or taps that are dirty. Before you start, always be sure your hands are clean. You may wear latex gloves when sampling if you'd like. Collect the sample using the following procedure. Remove any hose attachments, aerator, or screen on the end of the faucet or the tap. Ensure the faucet or tap itself is clean from contamination. Open the cold water tap to obtain a smooth flowing stream at a moderate pressure. Allow the water to run to waste for 2 to 3 minutes or for a sufficient time to clear the service line. This can be determined by waiting until the water temperature stabilizes. This is a good time to complete the sampling form. Reduce the water flow slightly to about a pencil width. Ensure that the water does not splash, but do not adjust the flow while you're doing the sampling. Remove the cap and keep it turned downward. Do not rinse the bottle, do not touch the inside of the cap or the lip or the inside of the bottle, and do not set the cap down. Fill the bottle to within ½ an inch of the top or to the line on the sample bottle, or as directed by your certified lab. Remove the bottle from the stream of water and immediately replace the cap. Do not over-tighten the cap or it may split. Replace the aerator or any attachments. Fill out the lab sheet and be sure to include your PWS ID number, sample date, time, the location, the collector, the type of sample, and the chlorine residual if your supply is chlorinated. Make sure you label your samples correctly according to your operation permit and/or your sampling plan. Bacteria samples should be collected early in the month to allow time for collection of repeat samples if necessary. Bacteria samples must arrive at the lab in time to allow analysis to begin within 30 hours of collection. If you ship samples in coolers, be sure the coolers are clean. If the finished water is chlorinated, the free and total chlorine residuals must be measured and reported on the sampling form. We will discuss chlorine residual measurement in another video.